this one. Make sure you follow, okay? 51. Mean and standard deviation. And you might say, like, by hand, Mr. Dixon, we've done that. I know how to do it. This is a different situation. So you're not even using your calculator really for this at all. This method is used when limited information is given about the set. You will be given percentages of values between them or the associated z-scores. Okay? If 68% of data points fall between the values that we know, then obviously it's plus or minus 1 standard deviation. How many gaps would there be in between the values if we know 68% is in between them? There are 2 gaps. One to the left, one to the right, 2 gaps. If you're told 95% of data, right, is in between the 2 points you're trying to find, there will be 4 gaps. So these are pretty straightforward. You've already seen them. Or 6. So 2, 4, 6. If you recognize these percentages, you know it's 2, 4, 6. By the way, 99.7, if I ever mention the majority of people, you know, sleep between this and this many hours, if you see this word, it's not just a random word. It actually refers to 99.7%. Okay? So it's not just a random. Keep going. These 2 formulas you have to have on your study sheet. Okay? And I didn't think of the order when I put the formulas down. I just gave you the formulas. Start here. Start with this one, then find the mean. So what is this talking about here? Upper value, lower value. So this could be grams, this could be mLs, you name it, days. Z up and Z low. Every value has a z-score. So the upper has a upper z-score. The lower value will have a lower z-score. Okay? And soon you're going to say Zia later. Okay? You'll have a weekend. That's my joke for today. So standard deviation mean. Once you have the standard deviation, you can plug it in here. So let's do a question here. I will skip 52. I will go to 54. Straight to 54. Some scientists are studying the female deer population in western Manitoba. One female deer weighed 110 pounds, which corresponds to a z-score of negative 1.15. Another female deer weighed 150, which corresponds to a z-score of 2.68. Determine the mean and the standard deviation of the female deer population. Okay? So to find the z-score, the standard deviation, we go upper minus lower, z up, z low. Okay? And so the upper, in terms of the actual weight, you go 150 minus 110. And the upper z-score is 2.68. So you go 2.68 minus, you got to be careful here, it's minus a negative z-score. Yeah, it's going to turn positive, exactly. Okay, 150 minus 110 is 40 pounds. And then if you subtract these two, you got to go 2.68 minus negative 1.15, or just rewrite it into positive. So that's 3.83, like that. So you go 40 divided by that answer, so your standard deviation is 10.44, in this case pounds. Okay. Can you use inverse norm, normal, CDF? Let's say you're stuck and you're like, I'm going to use that one. You don't know the mean and standard deviation, which is a must for those two, right? Can't use that one. So have this formula on your study sheet for sure, okay? What about the mean now? We have the standard deviation, so we're going to use this one. I'm just going to go P because I forgot the formula here. X minus standard deviation of the z-score. Okay. And here's where you have to pick. If you want to use 110 pounds as your value, sure, go for it. Minus 10.44. Which z-score do you have to use if you used 110? Negative 1.15. All right? If you wanted to use 150, you have to use this z-score. You both get the same answer, regardless of which method you use. This is 110 minus, actually, yeah, I'll 10.44 times negative 1.15. That actually turns into positive 12.006. So that is 122.01 pounds. That's your mean and the standard deviation that goes with it. I'll do one more. Let's go to I'm going to go 53. Back to 53 right here. This one. Generally means most of the time, majority of the cases. A mass in an Appaloosa horse is generally in the range of 431 to 533. Assuming that the data is normally distributed, determine the mean and standard deviation of this mass. Generally means 99.7. Write that down, 99.7% of the time. So in this case, I think it's helpful to think of the low range is 431 and the high is 533. Just hang in there for a bit, okay? What's the z-score of this weight? If it's 99.7, remember in the middle is 0. How many do we go to the left to get to this end here? Negative 3. How many to get to this end? Positive 3, right? So this is the z-score and the z-score for each weight. So to get the standard deviation, you just go 533 minus 431. Z up, okay, minus Z low. This is 102 divided by 3 plus 3 is 6. So it's 17 kilograms. What's going to be the average? Which one do you want to use? Let's use the positives here. 533 plus the z-score. Sorry. Standard deviation times z. The average is 584. Oh, something isn't right there. Houston, we've got a problem. What did I do wrong, guys? Is it minus, the formula? Yeah, it's minus. See? My bad. I'm just showing you what not to do. Always. 42. And why did I question my answer, you think? Where should the mean be? It should be right in the middle between these two values, right? I got 584. Didn't make any sense. Okay? That's how I caught it. I'll say 52 to 54 has these types of questions if you want to practice them.